Hi students, today we will discuss the subtopic pipelining under the computer architecture, and the course of the computer architecture is UEC 509. So before we will discuss the details of the pipelining, what is the pipelining, what is the importance of the pipelining, and how the pipelining can be executed in the processors, and what are the data paths of the pipelining. First of all, we will try to understand the sequence of execution of an instruction. As we know that to execute an instruction, we will have to follow the certain steps, and these are the steps. Initially, whenever we want to write a program, we will have to store the program in the form of instructions in the instruction memory. And whenever we want to execute any instruction, we will have to fetch the opcode of the instruction from the instruction memory and load it to the processor. So the process which is used to read the data, read the opcode from the instruction memory to the processor is known as fetching. So what will happen in during the fetching? The program counter will be a register which will be responsible to hold the address of the instruction which we want to fetch from the memory. The same address will move to the instruction memory, and whatsoever the address will be sent by the program counter, the opcode stored at that particular memory location will move to the instruction register. At the same time, the address will move to a adder circuit, and which will add the 4 to the whatsoever is the current address, and 4 will be added to that current address, and it will become the new address for the program counter, and which will be the address of the next instruction which will be executed after the current instruction. So once the opcode will be there in the instruction register, then whatsoever the opcode is received from the memory will have to be decoded, and this particular part, decoding of the instruction, will be done at the second stage. So the fetching of the instruction is the first stage or first step, and decoding of instruction is the second stage. So what will have to do in the second stage, or what the processor will do in the second stage, which is called the decoding of the instruction. In this particular stage, the processor will decode the received opcode from the instruction memory and will try to understand what type of operation will have to be performed, what is the type and location of the data or the operand which we will have to use during the execution of this particular instruction. So all these things will be done within this particular section. As we can see that decoding will be done over here, the type of operation will be come to know, then the registers will be identified, and the data, whatsoever the data is required for the registers, will be loaded to the temporary register, register A and register B. If there will be any immediate data, that immediate data will be moved to this sign extended block, which will convert the 16-bit converted into 32-bit decoding of the instruction. And next, third stage is the execution. This particular stage of the processor will be responsible to execute the operation. What type of operation will have to be performed? Either arithmetical or logical operation or any other type of operation will have to be performed. That particular operation will be performed within this stage. Okay, so ALU will be responsible to perform that particular operation, what type of operation we want to perform, and result will be available with the ALU output. Okay, and then the next stage is the memory access. If there will be need to access the memory after the completion of the arithmetical and logical operation, if the need of the instruction is to store the data to the memory, data memory, then the data memory storage or memory will be assessed during this fourth stage of the instruction. And if there will be need to store the result to the registers, write back in the form of write back, and then that will be happened in case of write back cycle. So if the instruction is required the memory access, then and then only the process will happen, or the process will execute in this particular cycle under the memory access. And if there is need to store the data whatsoever the result is prepared by the ALU, if it will have to store to the register, then it will directly go from the ALU to the registers, but that will go to the last stage or last cycle, that is called write back. So this is the sequence of events which will happen during the execution of an instruction. Under the normal circumstances, under the absence of the pipeline, for unpipelined structure, this will be the data path for unpipelined structure. In this, at one time, only one part will participate or one part will execute whatsoever the responsibility is assigned to that particular stage. Rest of the stages will remain idle, will not perform any operation. For example, let's suppose during the fetching cycle of the instruction, only this particular stage will be responsible to fetch the opcode from the instruction memory. At the same time, the rest of the stages will not perform any operation. When the second stage is decoding the opcode, whatsoever the opcode was received, then at that point of time, the rest of the stages will not perform any operation. So under these circumstances, one instruction, at least if we will assume that a processor is required or a processor is having the 5 different stages to execute one instruction, then at least that particular instruction is required 5 clock cycle to complete that particular instruction, because at one time only one stage will perform its operation, rest of the stages will not perform the operation. So this is known as unpipelined data path. Now what will happen in the pipelining? What type of modification or what type of enhancement will be done under the pipelining? First of all, we try to understand what is the pipelining. As we have already seen in the previous slide, the one instruction is divided into 5 different parts. In some processors there may be 3, or in some processor there may be 4 stages. So minimum 3 stages will be there for a processor. So number of stages will depend upon the what is the type of the processor. So now in the pipelining, what will happen? As per the definition of the pipelining, it is an implementation technique. This is a technique which is used to implement, in which the multiple instructions are overlapped in execution. So in this particular technique, the more than one instructions can also be performed. But this overlapping will not be visible to user. User cannot see this overlapping. User cannot see how many instructions and what type of instructions are executing by the processor. Now before we will discuss the detail of this pipelining, so for the better understanding, we would like to compare this pipelining with an example. Let's suppose there is assembly line in the automobile industry. As we know that in the assembly line of the automobile industry, there are so many stages and different operations have to be performed at the different stages of the assembly line. And each stage of this assembly line will have to contribute something towards the manufacturing of the car. Okay, so what does it mean? The meaning of this is the assembly line of an automobile industry, in which there are so many steps are there, and each and every step or each and every stage will have to contribute to the construction of the car. And all these manufacturing steps and all these steps will operate in parallel with each other, but on different cars. Similarly, in the case of pipeline, if we will consider that the 5 different stages are there for one instruction, and if we will assume that these instructions are instruction fetch, instruction decode, execute, memory read or write, or memory access, and write back, then what will happen? These number of stages will be arranged in such a way that more than one instructions can be executed at one time. So just on the similar line as in the case of the assembly line, for the pipelining, during the each and every clock cycle, new instruction will be initiated. So we will try to understand what is the pipelining with the help of this particular diagram. Let's suppose we are having a program and the instructions are stored in the memory in a sequence. Let's suppose this is the instruction I, the next instruction will be I plus 1, the next will be I plus 2, I plus 3, I plus 4, and so on. And let's suppose these are the different cycles. This is cycle number 1, 2, 3, 4, 5, 6, and so on. First of all, the program counter will send the address of the first instruction and will fetch the opcode. So during the execution of the first cycle, the opcode of the first instruction will be fetched. At this point of time, nothing else will happen other than the fetching of the opcode of the first stage. So what will happen during the second cycle? During the second cycle, the first instruction will enter to the second stage, and at the same time, the instruction number 2, which is I plus 1, will fetch the opcode, the whatsoever the stage assigned to the for the fetching will perform a parallel operation fetching, and whatsoever the second stage to whom the decoding function is assigned will perform the decoding of the first instruction. So during the second cycle, the second stage, which is the decoding stage, will decode the first instruction, and the first stage, which is the fetching, will fetch the opcode of the next instruction. And when the third cycle will appear, then the first instruction will be executed by the execution unit, second instruction will be decoded by the decoding unit, and third instruction, which is I plus 1, will be fetched from the instruction memory by the fetching unit, and this process will go on. During the first cycle, only one part of the one instruction is executing, but in the second cycle, two parts of the two different instructions are executing at the same time. So this is what is called overlapping. Overlapping of the processes, overlapping of the stages of the instructions. So when we will move to the fifth stage, then we will see that the write back stage of the data path will execute the instruction I. Memory access part of the data path will access the instruction I plus 1. Then execution unit of the data path will execute the instruction I plus 2. Then decoding part will done the decoding, and fetching unit of the data path with pipelining will be fetching the instruction I plus 5. Up to the point of fifth cycle, if we will see or if we will look at this, then each and every stage of the pipelined data path is busy to perform one task. As in the case of unpipelined, only one stage was busy to perform the task, rest of the stages remain idle. So but here in this case, each stage is contributing, or each stage is executing one part of one instruction. So if we look at up to the fifth cycle, then we will see that parallelly 5 different instructions, a part of 5 different instructions are executing by the 5 different stages of the pipelined data path. This is called pipelining, in which multiple instructions, more than one instructions are overlapped in execution. Okay, so all the instructions are executing but with different part. Okay, so during each cycle, the different parts of the different instructions are executing, and each execution part of this pipeline is called pipeline stage or pipe stage. Okay, if a processor which is having 5-stage pipelining, it means that will have the 5 different stages, and if a processor is having 3 stages only, then it means that particular processor can perform the 3 different stages at one time. Okay, so what is the machine cycle? The machine cycle will be the time required to complete the single pipeline stage. So whatsoever the time taken by the structure to complete the one stage of the instruction, that is called the machine cycle. So it is depend upon the slowest pipeline stage. So theoretically we can assume that all the speed of all the stages are same, but practically the speed of all the stages will not be same. So which time we will consider as a machine cycle whatsoever the time will be the slowest time of the pipeline stage. Okay, so this is the pipeline. So now what is the impact of the pipeline? So, and what is the goal of the pipeline? The goal of the pipeline designer is to balance the length of the pipeline stages as well. As we know that the each stage of the pipelining is performing the different operation. Fetching, one stage is performing fetching, another is performing decoding, third is executing, memory access, and write back. In this particular example, we can see that there are 5 different stages, and each stage of the pipeline is going to perform the different operations. For a best designer, he or she will have to keep in mind the length of the pipeline stages must be balanced. So if we will again compare it with the example, it is just similar to balance the time of the each stage of the assembly line in automobile industry. Okay, so if the pipeline stages are perfectly balanced, if we assume that all the stages of the pipelines are perfectly balanced, then how can we calculate the time per instruction? And that time per instruction of the machine can be calculated by using this equation, and this is time per instruction on the pipeline machine will be the time per instruction in the unpiped line. So whatsoever the time will be taken by the unpiped line divided by number of pipeline stages. Okay, so what are the different features of the pipeline? Number one is speed up. So how can we calculate the speed up? Speed up is depends on the number of stages in the pipeline. As we can see that the time taken per instruction in the pipeline is depend upon what? Number of stages of the pipeline. If the number of stages in the pipeline will be more, then naturally the time taken per instruction in the pipeline will be less. So more speed will be there. So speed up will depend upon number of stages in the pipeline. We cannot use the same resource for two different operations during the same clock cycle. What does it mean? The meaning of this is, let's suppose we are having one memory, and can we use the same memory in the same cycle for the two different operations? No, it cannot be. We cannot use the same resource for two different operations during the same clock cycle. This is the advantage. Pipeline reduces the average execution time per instruction. So as we have already discussed that it is reduce the pipeline time per instruction in the pipeline, so naturally it will also reduce the average execution time per instruction. We will try to understand the data path in pipeline format for DLX processor. Thank you.